Let's slice up one more thing, and this is this amazingly large pyramid. We would like to know the volume of this pyramid thing. So we slice it again. We assume that the total height of the pyramid is 80, and then the width is 100 meters, and we would like to know the volume. Let's draw the pyramid again, and then indicate the slicing which I used. Here is the pyramid, height 80 meters, length, side length 100 meters, and now pick a slice of height dz. And then we know immediately that the volume of a slice, dv, equals the area of the slice times the thickness. So the area would be a square. So I call this area of the square, and the thickness is this little dz. So we need to find the area of the square as we move up in the pyramid. And to do this, I need another graph and look at it from the side view. So let's draw the pyramid again, this time from the side. And we know that each length here is 50 and 50. And the total height is about 80. And then the slice is sitting right somewhere in here. Okay, and so this is like the dz. Which means the height I call z, and then this bit here is 80 minus z is the rest. And now I give this value here, this is what I need to know. There's a little bit not enough space. I call this w over 2, because I have it to the left and to the right, and together then this would be the length w of my square, the sides of my square. Now, there are two ways to find w. You can either use the formula for a linear decaying curve, or you use similar triangles. So let me use similar triangles, because this is something which we might not have used very often. So which are the similar triangles? So one is the one with the total height of 80 and the total width of 50. And then the other similar to it is the inner one, where you go to the slice. So then this height was 80 minus z, okay, and the other one was w half, which is our unknown value. And then we know that the ratios are the same, so that then 80 over 50 is the same as 80 minus z divided by w half. Now we want to solve this. So 80 over 50 is of course 8/5 equals 80 minus z divided by w half. And now I multiply by w half and I divide by 8/5. So I move the w half to the other side. And then I have to multiply with 5 and divide by 8. So I have 5, 80 minus z divided by 8. So 80 by 8 is 10. So this is 50 minus 5, 8z. And then I can indeed find my w to be 100 minus 5/4 z. All right, that wasn't so bad. So I have w. And from w, I can get the area of the square, which is, of course, w squared. And then I have dz, and so I can integrate this stuff. The small volume element is the area of the square times dz. So this would be then w square dz. And for w, I have the formula. So I need to square this guy and then dz. And let's do the squaring right away, because we have to do it anyways. So then this would be 10,000 minus 250 z, and then plus 25 over 16 z squared. The total volume then is the integral over dv, and I can just sub in the numbers. So it is the integral. Now we integrate over z, over the height. This goes from 0 to 80. Yeah, and then this 10,000 minus 250z plus 25 divided by 16 z squared dz. Okay, and again, it's a polynomial integration, which shouldn't be very hard to do. So let me just quickly do that. I integrate, I get 10,000 z minus, and then I have 125 z square, and then there's a z cubed divided by 3, so we get a 25 divided by 48 z to the 3 between 0 and 80. And then we have to sub in the 80 in all this. The first term is an 800,000. The next term you can compute is also 800,000. And then the last term, if you compute it, it will be 800,000 thirds. 800,000 divided by 3. Okay, so the first two terms cancel and the last term remains. So the result is 800,000 thirds cubic meters, which is about 266,666.6 repeated cubic meters. So that's the volume of the pyramid. For those people who know the pyramid formula, the volume is the length times the width times the height, and all this divided by 3. So let's also sub this in our formula. The width is 100, the length is 100, the height is 80, the 3 is 3, and so this is 800,000 thirds, and we get the same result. Okay, so the slicing method would be one method to prove that this formula is correct. So Tolo, did you get this? Do you understand this slicing method thing? Yes, Dr. Hillen. It's really easy, right? If you want to have B, you integrate dB, where dB is a little bacteria count. Or for the volume, you integrate dV. Or the area, you integrate the area. Or the mass, you integrate the mass. I really got it. So to make a Tolo, you do this.